Welcome to ClickMyProject.com.
Now we discuss about the product for scan test bandwidth management for ultra-large scale system on chip architectures.
Next we see the abstract for the product. Today's multi-core chip architecture requires no trivial test solution imposed by the relentless miniaturization of semiconductor devices, which have become much faster and less power hungry than their predecessors. That this trend has given a rise to growing popularity of system-on-chip design because of their ability of encapsulate many dispatcher types of complex IP core running at the different clock rate with different power requirement and multiple power supply voltage level. Many SoC based test scheme proposed so far they utilize the detected instrumentation, including test access mechanism and test wrappers. TAM are typically used to transfer the data between the SoC pins and embedded cores, whereas the test wrappers from the interface between the core and SoC environment. Solutions involving both DAM and wrapper accomplish such tasks as optimizing test infrastructure architecture or control logic, while addressing routing and layout construction or hierarchy of cores, scheduling test procedure and minimizing the power consumption techniques proposed in multi-minimized SoC test time. For example, the approach of encodes test for each core separately through the linear feedback shift register residing with time multiplexed automatic test equipment channels delivering data to successive cores. Similarly, a scheme of utilizing static residing to the test SoC, where all the cores share the single LFSR, the XOR logic test compression further guide the TAM access mechanism. This paper presents the several techniques employed to resolve the problem solving when applying scan bandwidth management to large industrial multi-core system on chip designs with embedded test data compression. This design poses to significant challenge to channel management scheme flow and tools. This paper introduced the several test logic architecture failure to pre-emittive test scheduling for the SoC design. The embedded deterministic test-based data compression, the same solution allowed to efficient handling of physical constraints realistic application. Finally, the state-of-art SoC test scheduling algorithm are re-architecture according to making the provision. First one, the set up the time effective test configuration and optimize the SoC pin partition and allocation of core level channel based scan data volume and more flexible crosswise usage for automatic test pattern equipment channel resources. Next we see the flow diagram for the product. The source input data bits to be applied per the router separate router architecture. This router architecture consists of master internal and slave memory. These components used to input for the overall NOC architecture designs and to slave for input and output based process to be used in the slave router memories, and the network interface to connect the master internal and slave memory in bidirectional manner. The switch selection process to collect all the data from master internal and slave router and to select any one of the data and to send all the routers in bidirectional manner, and the hope based master external memory to collect all the information and to select any one of the information and pass the another NOC design. Our NOC design structure is mainly based on the star topology based internal connection. So we analyze the hub to all the LFSR function to be generated and to create the test methodologies for the overall NOC architecture design and to passing the to cross to router architecture design. This router architecture design to analyze the each and every router and to match and mismatch the faulty router and the correct routers, and to analyze all the things and to check the whether the bits to be lost or the bit to be inserted for the overall data transmission based process, and to design the forecast for router architecture at the same is 2x2 router structure, and to calculate the next neighbor node estimation control for the overall star topology based NOC architecture, and to analyze the final destination router. This final destination router to be select any one of the router for the source, and to select the any one of the test for the overall NOC architecture design. All the control to be presented in the selection control logic. Then we simulate and synthesis the overall scan based NOC architecture design. This design to analyze the testing purpose to implement the forecast for NOC architecture design, and through synthesis performance to consider the hardware implementation source of overall scan based NOC architecture design. This is the overall flow for our required NOC architecture design oriented process. And finally we see the output for the product, and we select the simulation window and to select the simulate behavior model. Then to run the simulate behavior model after completed successful, then to open the iSIM project navigator. This navigator is used to simulate the overall architecture process. Then to apply the input data bits and the read and writing control signal and the selection logic for star topology selection control, and to process all the things and to generate the our LFSR generation process, and each and every section to be analyzed for overall scan test based NOC design process. This is the simulation window for simulate the our overall mesh based star topology based NOC architecture design. This is the overall signal. Then to select the preset function for generate 1, and to control the each and every writing sections for the 1, and all the things to be controlled by the 1 sections. This is the source selection logic. This is the what are the input to be passed in the which allocation. This is the destination selection logic for overall architecture bus. This is the scan input chain and the scan enabling functions for overall architecture functions. Then to run, then to set the reset function, and to passing the functions for overall architecture, and to apply the writing to be 0. Then to generate the final data bits output for the our overall architecture process. This is the sample designs for our architecture. This is the sampling section for the each and every routing section, and to passing the our overall architecture for NOC based designs. Thus the design to be represents for the our overall architecture. This is the passing logic for our the required output designs for our final design. This is the based scan based NOC architecture. This is the passing output for the overall output designs. This is the EID to be employee ID for the each and every router section, and the router to be secured and possible to be data in source to destination part for overall simulation purpose. Then we go to the implementation design. This implementation design to analyze the RTL and technological schematic. RTL schematic to represents the what are the logical path present in our overall NOC architecture design based process. This architecture mainly based on the star topology based structure for overall NOC design, and to implement the scan input based scan test based architecture for our required NOC design. This is the master internal and the network interface selection and switch logic, and the slave owned memories. These are the network interface to be bidirectional manner, and to analyze all the things. These are the overall circuit designs. The scan test technology to be present in our overall architecture. Then we go to the technological diagram. This diagram to represents the how many structure, what are the structure to be present in overall FPGA structure. These are the lookup tables and the buffer input output elements and the bounded input output. These are the overall structure. This is the wire connections and the overall structuring processing level. Then go to the design summary process. The design summary process to represents the how many logical structure to be represent in our overall architecture, and to represents the what are the timing summary for overall timing and the speed and the latency time, then the combinational path delay time for scan test based mesh to star topology based NOC architecture design. This is our the overall process for scan test based NOC architecture design.